Have you ever wondered how web applications seem to instantly respond to your actions? Whether you're clicking a button, typing into a form, or receiving live data, event-driven architecture or EDA is what makes it all happen. In this video, we're going to take a deep dive into how EDA works in JavaScript and why it's crucial for building efficient and scalable applications. Event-driven architecture is a design pattern where the flow of a program is determined by events. An event is essentially a signal or message that something has occurred. This could be a user action, a network response, or even an internal system message. JavaScript, particularly with its asynchronous nature, thrives on event-driven paradigms. This design pattern is foundational not only in the browser but also in server-side environments like Node.js. In the browser, JavaScript heavily relies on EDA to handle interactions. When you add an event listener to an HTML element, you're telling JavaScript to wait for a specific event, like a button click or key press, and then execute a predefined function when that event occurs. Let's break this down with some code. Here's a simple example where we're listening for a button click using JavaScript's addEventListener function. This function takes two parameters, the event type, in this case click, and a callback function that defines what happens when the event is triggered. Const button equals sign document.querySelector button, button.addEventListener click equals sign, console log button clicked. In this example, once the user clicks the button, the event listener kicks in and the action specified in the callback logging a message to the console is executed. Importantly, this happens asynchronously. JavaScript doesn't pause waiting for the click. It continues executing other code until the event is triggered. JavaScript's event-driven architecture is tightly linked to its asynchronous nature. At the core of this is the event loop. The event loop continuously monitors events and their callbacks, allowing JavaScript to handle multiple events without blocking the main thread. Events are added to a task queue and are executed in the order they arrive, but only when the call stack is clear. This is what allows JavaScript to handle things like DOM updates, user inputs, and API responses efficiently without freezing the UI. Events can be much more complex than just clicks. JavaScript provides a wide range of events, from user interface events like mouse move and scroll, to network events like ready state change for handling AJAX requests. Document addEventListener, mouse move, event equals sign, console.log, window addEventListener key down, event equals sign, console.log, const hr equals sign, new XMLT request, hr addEventListener, ready state change, equals sign, if xhr dot ready state equals sign 4, and then xr dot status equals sign 200. Console log data received, xr dot response text, xgr open get quote https api.example.com/data, xhr dot send. As you can see, JavaScript's event handling capabilities allow you to create highly interactive and dynamic user experiences by responding to a wide range of inputs and system states. But EDA isn't just useful in the browser. In fact, it's at the heart of how Node.js handles server-side operations. Node.js uses a single-threaded, non-blocking event loop to manage input and output operations, allowing it to handle thousands of concurrent connections efficiently. Const event emitter equals sign require events, const emitter equals sign new event emitter, my emitter on event equals sign our console log, an event occurred, my emitter emit event. Node.js comes with a built-in module called Events that allows you to create your own custom event emitters. Here's an example where we define and trigger a custom event using the event emitter class. This is useful for creating modular, decoupled systems where different parts of your application can communicate through events without directly depending on each other. By using the event-driven model, Node.js can efficiently manage I/O bound operations like file handling and network requests without blocking other tasks. This makes it ideal for real-time applications like chat servers or multiplayer games. Event-driven programming offers a huge benefit in terms of system design. By structuring your application around events, you can build more modular, maintainable, and scalable code. Each component of your system can operate independently, triggering or responding to events without being tightly coupled. This makes it easy to add new features to an existing system by simply wiring up new event listeners, without having to rewrite or heavily modify existing code. EDA is essential for building applications that need to be highly responsive and real-time. Web apps that update dynamically without refreshing the page, multiplayer online games, and real-time messaging apps all rely heavily on event-driven programming. To recap, event-driven architecture is a powerful design pattern that underpins how JavaScript handles both user interactions in the browser and asynchronous operations in Node.js. It enables developers to build scalable, responsive, and modular applications by focusing on events and the actions they trigger. If you found this video helpful, don't forget to like, share, and subscribe for more in-depth programming tutorials. Thanks for watching, and I'll see you in the next video.